That's what the system is packing as a Category 5 hurricane. And much of that will be within the eye wall. In that eye wall, which is that area that surrounds the eye, you will have that most intense wind speeds, but also the most torrential downpours of rainfall.
For 30 years, Evan Thompson tracked hurricanes across the Caribbean, guiding Jamaica through every major storm that threatened the island. In October 2025, Melissa appeared on his screens with pressure drops that broke Atlantic records and wind speeds that exceeded what his instruments could measure. What Thompson discovered in the data wasn't just a stronger hurricane. It was evidence that Earth's oceans had been transformed into something that could fuel storms beyond anything in recorded history. October 26th started like any other hurricane watch at Jamaica's Meteorological Service headquarters. Thompson pulled up the latest satellite data on Melissa and immediately knew something was wrong. The storm's central pressure had crashed to 892 millibars at landfall, tying it as the third strongest Atlantic hurricane ever recorded. Only 2 storms in history had gone lower. The satellite readings showed a T8.3 intensity estimate, the highest value ever recorded for an Atlantic hurricane. The previous record had stood since 1988. Thompson rechecked his instruments. Every system confirmed the same impossible readings. Melissa had exploded from a tropical storm to a catastrophic hurricane in under 18 hours. Normal intensification takes days. Every computer model predicted something weaker. Every forecast system underestimated what was building offshore. Gilbert had hit Jamaica in 1988. Ivan threatened in 2004. Those were powerful hurricanes that followed understood patterns. Melissa was different. The rate of strengthening suggested the storm was accessing energy that shouldn't exist in late October. Something about how Melissa was feeding itself didn't match anything Thompson had seen before. Climate scientists would later estimate that warming had pushed Melissa's winds 10 miles per hour higher than natural levels. But that alone couldn't explain what Thompson was witnessing. The numbers suggested something more fundamental had shifted. What he saw next in the storm's internal structure would only deepen the mystery. Hurricane Hunter aircraft penetrated Melissa's core on October 27th. The crew transmitted measurements that made Thompson question decades of atmospheric science. Wind speeds in the eye wall reached 241 miles per hour at just 709 feet altitude, among the highest recordings ever captured. The pilots reported birds trapped inside the eye, circling helplessly. What shocked Thompson wasn't the trapped wildlife, but the eye's structure. Most hurricane eyes wobble constantly, shifting and reshaping. Melissa's eye maintained an almost perfect circle just 12 miles across. It held that shape for days without deviation. The eye was compressed tighter than Thompson had ever observed, creating extreme conditions at its boundary. The Hurricane Hunter crew encountered turbulence so violent they had to abort the mission, marking only the 5th time in history that conditions forced an abandonment. Even legendary storms like Allen and Hugo hadn't maintained their structure with Melissa's consistency. Thompson studied the radar images. The eye wall showed organization that appeared almost mechanical in its precision. Weather systems are chaotic by nature, constantly shifting. Melissa maintained its structure with persistence that defied normal meteorological processes. The symmetry was exact, the density consistent, the spiral bands arranged with mathematical precision. Nature doesn't create perfection. Weather is messy, unpredictable, constantly reorganizing. Melissa's geometric consistency wasn't natural behavior. The storm's impossible structure had to be sustained by something equally unprecedented. Thompson pulled up ocean temperature data and found the first piece of the puzzle. Surface temperatures in Melissa's path had reached 86 degrees Fahrenheit, several degrees above normal. Caribbean waters were running nearly 3 degrees warmer than average. But what alarmed Thompson wasn't the surface warmth, it was what lay beneath. Most hurricanes weaken when they churn up cooler water from below. Cold water acts as a natural break. Melissa encountered no such break. The data showed deeper ocean layers were unusually warm, extending hundreds of feet down, creating what experts described as a vast energy reservoir. The Caribbean had transformed into an environment that could sustain the most powerful storms imaginable. Thompson calculated that traditional intensity limits might not apply. Melissa had access to enough energy to maintain peak strength for days rather than hours. Every time the storm churned the ocean, it found more fuel instead of the cooling water that should have been there. The basin was experiencing its warmest October temperatures on record. If this was the new baseline, future storms might maintain peak intensity for extended periods. The natural barriers that had prevented unlimited hurricane growth were disappearing, but the combination of unprecedented heat and Melissa's movement pattern was about to create something Jamaica had never faced. The most dangerous aspect wasn't Melissa's strength, it was its speed. The hurricane was moving toward Jamaica at just 2 to 3 miles per hour, slower than a person walks. The forward speed of 4.6 miles per hour was the slowest on record for any hurricane in this region since 1971. Traditional hurricanes move at 10 to 25 miles per hour. The worst conditions last a few hours. Melissa's crawling pace meant Jamaica would endure Category 5 conditions for unprecedented duration. Calculations showed the island could experience hurricane-force winds for up to 5 days, with 2 full days at peak strength. No infrastructure is designed to withstand such sustained assault. Buildings that might survive an hour would gradually weaken and fail. Forecasters warned this was a dire situation where tens of thousands would face hours of wind gusts above 100 miles per hour and days of torrential rainfall. The slow movement transformed wind from a momentary threat into grinding destruction that would systematically dismantle everything in its path. Melissa was forecast to dump up to 40 inches of rain. The combination of saturated soil and sustained winds would create landslide conditions the Caribbean had never experienced. Entire hillside communities might cease to exist. But Melissa's slow crawl created another danger nobody had anticipated. Health authorities issued an urgent warning. The catastrophic flooding was displacing crocodiles from their natural habitats. The reptiles were being forced into residential areas, searching for dry ground as rising water levels in rivers, gullies and swamps destroyed their usual territories. Residents were warned to avoid floodwaters entirely, keep children and pets away, and report any sightings immediately. The storm had transformed Jamaica's own wildlife into an additional threat. The storm had turned time itself into a weapon and nature into an enemy. But Thompson's most disturbing discovery was still ahead. Every forecasting tool was about to prove completely inadequate. The most unsettling aspect was watching meteorological science fail in real time. Every computer model, every forecasting system consistently produced wrong answers about Melissa's behavior. The global forecast system, European model, and specialized hurricane systems all generated different scenarios. None captured what the storm was actually doing. The satellite images resembled Western Pacific super typhoons, with intensity estimates at levels unprecedented for Atlantic hurricanes. Thompson confronted an uncomfortable reality. Melissa was operating beyond the parameters existing systems understood. The models weren't failing because of computational errors. They were failing because the storm exhibited behaviors that hadn't been programmed into them. Traditional forecasting relies on historical patterns. When storms behave within established parameters, models predict development accurately. Melissa violated these patterns completely. Each forecast run produced different results, because the computers were trying to predict something they had no framework to understand. Thompson found himself relying on real-time observations rather than forecasts, essentially operating without the tools that defined modern meteorology. The failure forced him to acknowledge they were dealing with a phenomenon at the edges of current understanding. Melissa was evidence that hurricane science itself might need fundamental revision. The model failures revealed something troubling. The tools that had given meteorologists confidence were proving inadequate for storms in a warmed climate. Emergency management systems, building codes, evacuation procedures, all based on historical behavior. If hurricanes like Melissa became common, the entire framework for dealing with extreme weather would need reconstruction. Thompson's final analysis would explain everything and reveal what hurricanes had become. On October 28th, Melissa's eye wall crossed Jamaica's coastline with winds of 185 miles per hour and pressure of 892 millibars, tying two records for the strongest Atlantic storm landfall ever recorded. This was the third Category 5 hurricane of 2025, making it only the second year in history with more than two such storms. 4 out of 5 hurricanes in 2025 had been Category 4 or 5, the highest percentage ever observed. Climate analysis revealed that warm sea temperatures had increased Melissa's destructiveness by up to 50% compared to conditions without climate warming. Along Melissa's entire path, the unusually hot ocean temperatures were 500 to 800 times more likely because of global warming. This was the fourth storm in 2025 to intensify by at least 50 knots in 24 hours, tying 2025 with 2020, 2005, and 2008 for the most rapid intensification events ever recorded in a single year. The perfect eye structure, the unprecedented ocean heat, the slow destructive crawl, the displaced crocodiles, the failure of forecast models. They weren't separate anomalies. They were connected symptoms of a single change. The atmosphere and oceans had crossed thresholds that allowed storms to behave in ways previous generations never witnessed. The Caribbean had transformed into an environment where theoretical limits of hurricane intensity were no longer theoretical. The natural barriers that had prevented storms like Melissa were being systematically removed. The warm water extended deeper. The atmosphere held more moisture. The steering currents weakened, allowing storms to stall. Every factor that limits hurricane destruction was shifting in the direction that removes those limits. Thompson understood that Melissa wasn't a messenger from the future. It was evidence the future had already arrived. The rules that had governed hurricanes for thousands of years were being rewritten in real time. Melissa proved that Earth's atmospheric system had entered new territory, and humanity's preparations were based on a climate that no longer existed. What Thompson witnessed would reshape hurricane science because Melissa demonstrated that the impossible had become inevitable. The storms that theory said were only possible in extreme scenarios were now appearing in regular seasons. The atmospheric conditions that should have been rare were becoming normal. The tools built to predict and prepare for hurricanes were proving inadequate for the reality unfolding. The veteran meteorologist had looked into Melissa's data and seen evidence that humanity had crossed into an era where nature's most powerful forces would regularly test civilization's limits. The revelation wasn't in any single measurement. It was in the pattern showing that Earth's climate had shifted enough to create storms operating by different rules than those that came before. The impossible had become normal, and Thompson's data proved it.